Earth, like many other rocky objects in the solar system, has been damaged by asteroids in the past, some of which have even influenced the evolution of life. For instance, the non-avian dinosaurs perished 66 million years ago when a 6-mile-wide asteroid collided with Earth near Mexico's Yucatan Peninsula. This mass extinction was brought on by the collision. The dinosaurs that once ruled the Earth had a lot to offer. The large, strange reptiles kept it under control for millions of years, either turning into birds or leaving behind fossilized skeletons. But something was lacking. The dinosaurs didn't have a space program, according to Katherine Calvin, NASA's chief scientist, to assist them to prepare for what was coming. But we do now. That's exactly what NASA did recently when a spacecraft destroyed itself by crashing into an asteroid. What took place when NASA impacted the asteroid, and if we are powerless to stop an asteroid from hitting us, how concerned should we truly be? Join us as we explore the terrifying announcement about an asteroid hitting Earth by NASA chiefs. Bennu is a top-shaped debris pile that has been orbiting the Sun in relative solitude for hundreds of millions of years. The asteroid, which measures approximately 1/3 of a mile across in its center, has a remote possibility that Bennu will collide with Earth in the next hundreds of years. Since the asteroid Bennu was discovered in September 1999, astronomers have used ground-based telescopes to closely follow the asteroid's orbit, including Puerto Rico's renowned but now defunct Arecibo Observatory. With the aid of these facts, astronomers were able to reasonably anticipate where Bennu would be in a century. As a possibly hazardous asteroid, Bennu is more than 460 feet, 140 meters broad, and has a probable approach distance of 4.65 million miles to Earth. According to a 2014 research, there was a 0.037% chance that the asteroid will hit Earth between 2175 and 2199. However, up until recently, simulations have encountered problems after September 2135. Bennu will likely pass by Earth in 2135 at a distance of between 75,000 and 330,000 miles, which could bring the asteroid closer to the planet than the Moon. Bennu has almost no chance of striking Earth at that time, but depending on how closely it approaches and where, our planet's gravity might change the asteroid's orbit and place it on a collision course in the future. The confined areas of space that Bennu would need to traverse in order to prepare for an impact have been determined through computer simulations. The crucial question is whether any of these keyholes, which range in size from a few hundred feet to a few miles, will be traversed by Bennu's actual course in 2135. Scientists must use previously unheard-of precision to map Bennu's present trajectory, as well as anything that might have an impact on its future course in order to provide an answer. As NASA's first and humanity's third attempt to sample the surface of an asteroid, OSIRIS-REx landed at Bennu in late 2018. The spaceship is currently returning to Earth to deposit the priceless material after snatching a dusty, pebbly sample in October 2020. But before it took a sample, OSIRIS-REx spent over 2 years orbiting and researching Bennu, a planet covered in ruins. According to the latest research, Bennu will pass by Earth's surface in 2135 at a distance of precisely 123,000 miles, plus or minus 6,000 miles. This discovery eliminates many previously discovered keyholes, but other keyholes and potential collision paths remain within the orbit's margin of error. The team was then able to update their projections regarding Bennu's collision risk. The team, led by Davide Finocchia, a navigation engineer at NASA's Jet Propulsion Laboratory, arrived at its new estimate by repeatedly measuring Bennu's distance from Earth between 2019 and 2020 and pinning it down to an accuracy of around 7 feet. The Empire State Building and the Eiffel Tower's separation can be calculated to be within a few thousandths of an inch with that level of accuracy. Despite the somewhat increased likelihood of impact, Bennu's hazards shouldn't keep anyone up at night. There is a greater than 99.9% chance that Bennu won't collide with Earth in the ensuing 3 centuries. Nevertheless, a collision with Bennu would have catastrophic regional effects. The energy of an impact would be equivalent to more than 1.1 billion tons of TNT, or around 2 million times that of the deadly port explosion that occurred in Beirut, Lebanon last year. The asteroid itself, or even OSIRIS-REx's data, aren't to blame for the persistent uncertainty around the space rock's future trajectory. It originates from the outer solar system. Only one possible follow-up target for OSIRIS-REx has been identified so far by the team, the near-Earth asteroid Apophis, which will pass relatively close to Earth in April 2029. But what precisely is this asteroid that so many people are concerned about? The enormous asteroid 99942 Apophis, which has a high likelihood of striking Earth, was long regarded as one of space's most deadly asteroids. The 370-meter asteroid's course toward the globe at the time of its discovery caused many people to worry that an actual impact would occur. The asteroid's diameter was once considered to be 450 meters, but that would make it roughly half the size of the 828-meter Burj Dubai, the highest man-made structure in the world, and taller than the 381-meter Empire State Building and 324-meter Eiffel Tower. For comparison, later calculations reduced the length considerably. Eventually, experts estimated it to be about 370 meters. Apophis was categorized as an Arton-class asteroid, which means that although most of its time is spent inside the Sun, its orbit does cross that of the Earth. After the projected close flyby, it's expected to be reclassified as an Apollo-class asteroid because of the larger orbit that it now has. The orbit crosses over the Earth's as it is an asteroid, the Arton class. Many people were concerned that it would have hit the planet because of its proximity, size, and speed. It orbits the Sun at a speed of around 30.73 kilometers per second and completes an orbit in roughly 0.9 Earth years. Initially, many people were concerned that the asteroid's course might put it in danger of doing just that. When anxiety over this possibility peaked, Apophis caused a stir by becoming the first asteroid to receive a 4 on the Torino Impact Hazard Scale in 2 years. Although even from the start the risk was never that great, the likelihood that such an impact wouldn't happen appeared very high. However, there were still reasons to worry that an impact would occur, and these were related to the gravitational keyhole's presence. In essence, this is a small area of space where a planet's gravity is present. The orbit of an asteroid may be changed if it happened to pass through the keyhole at the correct moment. At first, it was believed that Apophis could pass through the keyhole when it was scheduled to travel by Earth in 2029. If it did, there was a potential that its orbit might be changed, putting it in danger of colliding with our planet in 2036. However, more computations revealed that this was unlikely to occur. What kind of damage, if any, would Apophis cause? The precise degree depends on the makeup of the asteroid, thus it's unknown. However, even the most optimistic projections show how disastrous it would be. NASA's Sentry Risk Table anticipated that Apophis would strike the planet with a force equal to 1,200 megatons of TNT when it was still on it. When a strange asteroid exploded above the Siberian wilderness in 1908, it was compared to the Tunguska catastrophe, which was thought to have been equivalent to between 3 and 10 megatons of TNT. Even the Tsar bomber, the heaviest nuclear weapon ever tested, only had the explosive power of about 50 megatons of TNT. That is not to argue that it would have the most disastrous effect on the world ever. Every 800,000 years or so, an asteroid roughly the size of Apophis is thought to strike the Earth. According to a Curtin University study, an asteroid with a size estimate of around a kilometer did in fact strike Southeast Asia some 800,000 years ago. In addition, it was calculated that the asteroid that triggered the Chicxulub impact, which many people think was what killed off the dinosaurs, had a diameter between 11 and 81 kilometers and had a force greater than 100 million megatons of TNT, or 100 teratons. The asteroid explosion above Chelyabinsk, Russia on February 15, 2013 is the last big asteroid impact that is known to have occurred. Although this asteroid, which was only 17 meters wide, did not cause any fatalities, the shockwave from the explosion caused 1,500 people to require medical attention and broke windows in 6 separate Russian cities. It's almost unavoidable that the Earth will still be passed by Apophis in 2029, specifically on April 13th, but at a distance of fewer than 32,000 kilometers, 20,000 miles. This is significant since it will pass by closer than a lot of geosynchronous satellites and is the closest asteroid of this size to have ever been observed. In fact, it will be so close that everyone in the Eastern Hemisphere might view it without the aid of binoculars or a telescope. But is there still any chance that an asteroid may hit Earth? Yes, technically. According to NASA, there is no chance of an asteroid hitting the Earth in the next 100 years. However, this prediction only applies to asteroids that are traveling in the direction of Earth and the Sun, or from the front. asteroids approaching Earth from the back or away from the Sun are still infamously challenging to find. For instance, asteroid 2021 SG, measuring between 42 and 94 meters in size, sped past the Earth on September 16th last year, and astronomers were unaware of its existence or that it had done so until the next day. So can an asteroid impact be avoided? Even though it's unlikely, an asteroid's impact remains one of the most devastating natural disasters that may happen. To determine whether any close asteroids represent a threat to the Earth, astronomers from all across the world, including those at NASA's Planetary Defense Coordination Office, PDCO, monitor all nearby asteroids and compute their trajectories. The Double Asteroid Redirection Test DART mission is one strategy proposed by NASA and the Applied Physics Lab at Johns Hopkins University. NASA and other space organizations have been looking for asteroids with routes that cross Earth's orbit and anticipating their future motions for many years. The objective is to comprehend the risks we encounter over millennia so that we are not taken by surprise. In contrast to how dramatic and enjoyable Hollywood movies portray it, we don't want to be in a scenario like that in the real world. More than 95% of the projected total of 890 larger than a kilometer wide near-Earth asteroids have been discovered thus far, and none of them will present a threat to Earth's surface until at least the next few centuries. Although many of these objects have not yet been found, asteroids as small as 140 meters, 460 feet across, may potentially wreak havoc on an area the size of some US states. As of late 2021, only around 10,000 of the 25,000 near-Earth asteroids that are at least 140 meters broad predicted by computer models have been discovered. One of our only options would be to use nuclear weapons adjacent to a huge asteroid if it were identified only a few months before impact. Part of the asteroid's surface would be vaporized by the blast's X-rays, producing ejecta that would work like rocket propulsion and move the asteroid, hopefully, just far enough to divert it from a collision course. However, if a small asteroid were discovered well in advance of its anticipated impact, the problem may be solved without using nuclear weapons. It is possible to send a kinetic impactor, a quick spacecraft like DART, to hit the asteroid and significantly alter its orbit. That slight divergence would result in a significant alteration in the asteroid's trajectory over many years, enough to make it harmless. And now, for the first time ever, a planetary body's orbit has been altered by humanity. The DART spacecraft collided with the asteroid Dimorphos on September 26, as the mission's goal of practicing shielding Earth from possible hazardous future impacts came to an end. Since then, scientists from all around the world have examined the results of humanity's first-ever attempt to reorganize the solar system using a variety of telescopes both on Earth and in space, with sensors across the electromagnetic spectrum. Dimorphos' orbit around its larger partner, Didymos, was slowed by 32 minutes, or around 4%, as a result of the impact caused by DART, according to NASA. The larger effect begs crucial concerns about the makeup of Dimorphos and similar asteroids, as mission planners would have considered lowering Dimorphos' orbit by just 10 minutes a victory. So what do we know about objects like Dimorphos asteroids? Recent unmanned asteroid flights by NASA and the Japanese Space Agency have improved our knowledge of tiny astronomical objects. We now know that many of what were originally thought to be solid chunks of rock or mineral are actually looser agglomerations of material that behave almost fluidically like balls in a ball pit. Asteroids are not all the same, Dr. Thomas Statler, the top NASA scientist working on the mission, said. Most of them have been shattered and accumulated many times. We know they are objects with diverse surfaces. What we can do is use this test as an anchor point for our physics calculations. Images of the hit revealed tons of debris being thrown in all directions, eventually leaving a 10,000-kilometer dust trail behind Dimorphos that almost resembled a comet. With additional information from the experiment and the consequent findings, scientists are continually revising their theories for the size and mass of Dimorphos and Didymos. However, they believe that a portion of the impact's greater than expected effect is due to the debris' recoil after being thrown into space by the collision. Even while slowing the asteroid by merely 4% may not sound like much, the DART researchers said the experiment gives them hope that given enough time and notice, a harmful asteroid may be diverted away from the Earth. NASA may send a mission to investigate the asteroid and decide how to get that small nudge so that the asteroid crosses over Earth's course either before we get there or after we go by, ideally with decades of warning. The difficult part will be getting that heads up. A long-awaited infrared space telescope that can identify potentially dangerous asteroids and comets that are close to Earth is now being built by NASA. Budget problems are preventing the NEO Surveyor, as the project is known, from starting until 2028.